Hello everyone, welcome to PIGTONIC, a brand new deep brain stimulation. Before we get started, let me introduce you some main information about the product first. The movement disorder like Parkinson's disease or epilepsy are easily found in our world, especially depression from various reasons that happen on Earth right now. Normally, people would think that taking a pill is the best way to kill the disorder, but actually, if you're treating along with the deep brain stimulation, you will experience the best effective way to get rid of those disorders. So, to prevent that, this is a closed-loop deep brain stimulation from us, PIGTONIC. By using implanted pulse generator to generate an electrical signal, sending through an extension lead into the electrode to stimulate a located area. Moreover, it can also monitoring and give you a feedback. Now, let's get to know more about PIGTONIC. This is our table of contents, and the next one is the block diagram. There are two main parts, which are electrode and pulse generator. The process starts from an electrode receives a signal and then sent to a local field potential sensing module or the green one. After amplifier and filter, the signal is sent to the controller or the blue one to convert a signal to pulse generator or the yellow one, and classify adjust the last signal which will send back to the electrode to stimulate the brain.
Now, let's come to the lead and electrode part. First, before going to our electrode, I will briefly explain about the type of electrode links, which are conventional electrode and cemented electrode. The conventional electrode or the electrode links is the electrode that can stimulate the electrical fields in symmetric ways or allow the links in far direction up to the stimulating threshold. The links of the electrode will act as the cathode in stimulation process, which for the conventional electrode will be monopolar stimulation. On the other hand, the cemented electrode, which you can see from the picture that this type of electrode will divide itself into the small part in each layer of the links and also stimulate in asymmetric electrical field by the bipolar stimulation, which will make it can target the location more specially than the conventional one. For the more detail about the monopolar and bipolar stimulation, this will be explained more later in the pulse generator part. And now, let's come to our electrode design. We prefer to use 1331 directional electrode design, which is the design that is mostly used in deep brain stimulation electrode nowadays, and also be the one that has already been approved by FDA to be the standard directional electrode. Moreover, this design can combine both advantages of the conventional and cemented electrode, that we want to use them to access all the targets in every brain area that we want, such as for the small brain fiber stimulation. Using the segmented electrode mode function to target the fiber will be a better choice because it can decrease the opportunity to stimulate other non-targeting brain tissue areas. However, the stimulation threshold of the segmented electrode is still lower than the conventional electrode. To stimulate the large brain fiber or the fiber that is far away from the implanted position, it still requires the ability of the conventional electrode links. For the material, we decide to use platinum iridium alloy in the electrode part, and for the insulator or the lead, we will use polyurethane to be the main insulator because of its biocompatibility, and it is the most used material in deep brain stimulation electrode links manufacturing. And as you can see that our electrode has a contact surface, which is surface will attach with the wire along the extension lead. And for the arrangement of the wire in the lead, as you can see in the picture, we try to separate the wire together because we want to prevent the opportunity to cause the shocking to the circuit of the pulse generator, and also want to prevent the chance to have the signal interfere together. And for the outer dimension, we decide to use as small as we can, which we want to decrease the interspace in surgical process, but still can contain our wires in the lead, which will be 1.27 mm reference from the Medtronic standard.
Let's move to the connector. The connector is connect the directional electrode to the pulse generator by using a conducting coil, which will have around 8 wires because we use 1331 contact. And we also use a technique from Bausil's engineering as a reference from blocking and using platinum iridium as a conduct material. And the last one is the burr hole. It is implanted in your skull to unclose the hole and lock the extension lead from moving or shaking. And we use polyurethane as a material because we need it to be an insulator.
The implantable pulse generator is a part that is implanted in the chest of the patient. It mainly contains the electrical circuit and its battery. For the closed-loop DBS system, the circuit takes a role in sensing brain activity for feedback control and generating electrical stimulations. The sensing circuit is used to preconditioning the brain local field potential or LFP before it gets analyzed. 5 biomarkers including low and high range frequency are used to detect abnormalities of the brain, such as Parkinson's diseases, epilepsy, and major depression. The LFP that is received from the electrodes undergoes signal conditioning stages including amplifications and analog filters. The filters divide the signal into 2 frequency ranges according to the 5 biomarkers, low and high frequency. Then, the signal is amplified once again with programmable gain to get to your desired resolutions. Finally, the clean signal is sent for analysis and disease classifications in the control unit to adjust a suitable stimulation for instant treatment. Our neurostimulation type is a single source with the current control stimulation, which provides better safety than the voltage control. With the use of an adjustable current source and edge-bridge architecture, it is capable for biphasic stimulation with an active charge balancing, which provides the control of both cathodic and anodic pulses. The current also includes the output current sensing for the feedback control for better accuracy, precision, and shorter circuit detection for safety concern. Our system provides alternatives for both monopolar and bipolar stimulation at any contact of the lead. This way, you will be able to target different neurons with different shapes of electrical field of the stimulation. It also allows you to customize a wide range of pulse amplitude, pulse width, and pulse frequency.
Arriving at the batteries, we choose to use silver vanadium oxide hybrid cathode battery as our batteries. With the reason of that, it has high voltage densities, which means that it's going to have a long usage, as long as 4 years of service. And moreover, it's very popular in implantable devices such as implantable cardiac defibrillators or ICDs. And it has low battery impedance. And the most important one is that it has reliable end of service warning, as the battery will start to discharge part by part and voltage will drop slowly, not just drop from 3.2 voltage to 0. Moving on to a voltage regulator and rectifier. We choose to use a model called LD39020 voltage regulator ICs for our regulator because it has a wide range of voltage in trends, which is going to fit the condition that our batteries is going to discharge in the future. And moreover, it has a very high accuracies and low battery consumptions. And as you can see on the right hand side, it is an example of a circuit for the regulator. Moving on to the pulse generator housings. Our pulse generator will be made from welded titanium alloy because it has high corrosion resistance and it is biocompatible to human tissues. For the components, we have divided the component into 4 main parts. Begin with the case, which has duty to protect all of the internal component. The nest, which has duty to protect and support the circuit board. The weld band, which protects the whole internal compartment from the laser during the welding, and the header, which has duty to connect the circuits to outer components such as the electrodes. And as you can see on the left hand side is shown the diagram of our pulse generators. Number 1 and number 8 will be the case. The nest will be represented by number 2 and number 6. The volt band will be represented by number 5, and the header will be represented by number 7. And for the rest, the number 9 is the batteries, while number 3 and 4 are the circuits and the receiving coil respectively. Moving on to the safety, beginning with the isolating circuit. Here we use 2 diodes in order to control the current directions for it not to backflow or flow in the wrong directions. And then we have the EMI shield, which we use a platinum in order to shield our circuits from electromagnetic wave interference, either from the inner circuits or from the outer parts.
For the user that needs to have an MRI scan, 1.5 Tesla is the safety margin. Our device attaches some safety features such as 1. EMI shield, which prevents the system and the circuit from the radio frequency. Second one is a minimal ferrous material and locking platform. Decrease the possibility of the unintended device and lead movements due to the magnetic pull. Protection diode isolate the device from the user and prevent device failure due to the electromagnetic. Next part, we are going to talk about the navigation system. In this part, I will introduce you how doctors can deliver DBS leads to the patient precisely. The method that we recommended is the frameless and fiducial system, since there is no need to put the frame during the MRI, which will reduce patient anxiety before performing an operation. Also, when patient doesn't have to wear the fiducial, it helps reduce one of the invasive methods, meaning it is less harmful. The operating instrument include Stimulation S8 and its software. Stimulation is the navigation software and the monitoring station that ensures the performance of the doctor during surgery. Also, this station plays an important role in providing information that needs for delivering the lead. The second one is O-arm imaging system. The O-arm system is the intraoperative 2D and 3D imaging device that is developed to suit to surgical workflow demands. The third one is the neck frame platform. It's the platform that used to deliver the DBS leads. The last one is the PIG lock, that is the device that used to lock the lead wire that we have already mentioned. The operation of implanting can be divided into 4 main parts. The first one is imaging, getting a couple of MRI sets, volumetric 3D, T1 and T2 turbo spin, and imaging from the CT scan. Then doctor will determine the target for implanting DBS leads. Comprehensive function and anatomical information-based targeting seem to be the best way for targeting the stimulated area. By using brain atlas, T1 and T2 maps, neurophysiological information, and the real surgical data used to increase accuracy of the doctor's decisions in targeting. Moreover, those images are required for best integration to perioperative O-arm imaging. The second one, surgical operation. At the beginning, the doctor will use the O-arms to scan the patient and register the trajectory to the surgical planning system. Third one is the microelectrode registration and macro-test stimulation. Microelectrodes is used to ensure and mark the area of the real DBS leads to be implanted. After the implant DBS leads, doctor will awake the patient and perform the testing simulation. The last one is the lead ensuring and implanting pulse generator. After lead is injected into the body, the procedure continues under the general anesthesia. After the scalp was closed, the lead extender and pulse generator was implanted. Before being delivered to the patient, the device needs to be tested. Let's begin with the pulse generator. We test on the software and hardware and also the error notification. The lead and extension mostly be testing on the mechanical property and required function. The biocompatibility, for example, we test cytotoxicity, sensitization, and irritation tests and others. And the last one is the most important is sterilization. Our device sterilizing using the ethylene oxide. DBS or deep brain stimulation is a technology that improves the quality of life for the patients with a movement disorder or other symptoms such as OCD or depression. parallel with taking drugs by stimulating the performance of the abnormal areas in the brain. PIGTONIC provide a high performance and safe closed-loop DBS that can adjust the stimulation automatically. More specific stimulation means more benefits but fewer drawbacks. Our members include Pishpavin, Supalada, Nathamon, Visarut, and Gorovitz. Click the link below the video if you want more information. And this is the end of the video. If you have any question or advice, please leave us the comment. Thank you for listening.